Hello everyone. Today we will be reviewing factoring. Factoring is when you take an expression and you go backwards and figure out what multiplies to give you that expression. So I'm going to be first looking at GCF type of factoring, also known as greatest common factor. Okay, and I'll use this as an example. Here we have an expression that's made up of two terms. We know it's two terms because this subtraction sign separates terms. Subtraction and addition sign separate terms. So first, we have to figure out how do you recognize greatest common factor or any type of factoring. You have to look at the characteristics. So here I notice that these terms both can be divided by a common factor. That's how you know it's greatest common factor. Clear, 10 and 20, they're both divisible by 10. And again, that's the greatest common factor. There are other factors that they have in common, but you're always looking for the greatest. So whatever that common factor is, you want to bring that down to the next line. Now what you should also notice is that they both share x's, okay? So both terms have an x. So you always want to pull out the smallest one. Okay, so this is x to the second and this is x to the first, so which one's smaller? X to the first, since they both contain x to the first. That's why. Now once you've figured out what the common factor is, so altogether it's 10x, you open up a parentheses. Now divide each term by the common factor. So here, divide that by 10x. Here, divide that by 10x. So let's see what we result with. 10 divided by 10 is 1. We don't need to write 1, but we can if you want to. Then x squared over x is just x because you subtract the exponents, right? 2 minus 1 is 1, so x to the first. Bring down that minus sign. 20x divided by 10x is just 2. And you're done. Okay? You could always check your answer by multiplying that, and you should get back to the original problem. Okay, so that is greatest common factor. Again, the characteristics is just look for if terms have something in common. Doesn't always have to be a number, can just be a variable or vice versa, or both as in this example. Okay, next we have what's called difference of squares. I like to call it just DOS for short. And it's appropriate because in dos there are only two terms, and in Spanish dos means two, so if you want to think of it that way. Okay, so let's take a look at something like this. So in difference of squares or dos, there are only two terms and it's always separated by a subtraction sign. Cannot be addition in difference of squares, hence the word difference. Now, once you figure out its difference of squares, open up two parentheses and take the square roots of each term. So what's the square root of x squared? X. So write that here and write that here. What's the square root of 36? Positive 6 and negative 6. And that's it. That's difference of squares. Okay? Again, characteristics here are two terms separated by subtraction, and obviously they have to be perfect squares. So it can't be like a number like 18 or 20. You know, it has to be a number that has a square root. Okay, that's difference of squares. Two terms. Now let's jump up to three terms. Okay, I like to call this PNS. It stands for product and sum. Okay. I'll use this as an example, x squared minus 11x plus 18. So here in product and sum, there has to be three terms. And it has to start with a leading coefficient of 1. See, notice here, there's a 1. So in order to use this method, product and sum, these are the characteristics. Okay, so now what I do, and your teacher might have taught you differently when you first learned about factoring, but this is how I do it. I set up a P standing for product, and it's always the last number. The sum is always the middle number. You're looking for two numbers that when you multiply them, multiply to be 18, and when you add them, will add up to be negative 11. So you should know that that would be negative 9 and negative 2. Negative 9 and negative 2 multiply to 18, and they add to be negative 11. Once you figure that out, once you figure out the number combination, you want to open up two parentheses. Whatever this variable is, split it up, so x, x. Then all you have left is to fill the numbers, so negative 9 and negative 2. And that's it. And again, for all of these problems of factoring, to check, just multiply it out. You should always result back in the original problem. Okay? Next we have something that I call, it's not the actual name of it, the Aussie method, also known for Australian method. This is a method also that is learned in Australia in order to do these types of trinomials. So this is also a 3-term problem. However, in these problems, you're going to notice that the leading coefficient is not 1. It's something other than 1. So very first thing before you even begin or think, oh, this is the Australian type problem, check to make sure that this number here is not the greatest common factor, because sometimes if it is, then you're going to do this problem more complicated. You'll still get the problem right, but it'll just be more complicated. So always check if that's the greatest common factor. Well, it's obviously not, because 2 doesn't go into 3 or to 5. Okay? So now once you've established that this is the Australian method, you take this number and you multiply it to the last number, and that's your product. So negative 10. Sum is still the middle number. And still going about this the same way. So you're trying to figure out what two numbers multiply to be negative 10, and when you add them, add to be 3. That would be positive 5 and negative 2, right? Because 5 times negative 2 is negative 10, and when you add them, it adds to 3. Now in the previous problem, you just have to put them in the parentheses, but not in this. This one's a little bit more complicated. So let me show you how it's taught in Australia. You start by taking the numbers that you found to work, so 5 and negative 2. And I kind of just put a little space between them. Okay, now put fraction bars and take that first term and put it under, but split up that x. So 2x here, 2x here, not x to the second. Next, see if you can reduce the fractions. I see that in the first one, it cannot be reduced. So since it can't be reduced, you write it as it is from bottom to top. So 2x plus 5, because 5 is positive. Now the other fraction, however, can be reduced. You should notice that negative 2 over 2 is negative 1 over 1, right? So now that you've reduced it, now you can do bottom to top. So 1x minus 1, or just x minus 1. And that is your final answer. Okay? All right, we got two things left to talk about. So now let's take a look at a problem where you might think for a second it's Aussie method, but it's not. So this is a little bit, these can be a little tricky. So let's take a look at something like this. So let's look. So you see this problem, you think, oh, this is 3 terms and there's a number here that's not 1, so this has to be Australian. Incorrect, because the first thing I said was check to see if this number can go into the other numbers. Is it the greatest common factor? And it is. 2 can be divided into these numbers. So first, always check for the greatest common factor. If you have one, like in the first example, pull it out and divide them all by 2. So we're left with x squared plus 5x plus 6. Okay? Now, once we've done that, look inside here. This should look like a product and sum problem because it is. The product is the last number and the sum is the middle number. So what two numbers multiply to 6 and when you add them add to 5? That would be 2 and 3, right? Okay, so now this problem you will turn into 2 parentheses and fill the numbers in. X plus 2, x plus 3, and this 2 that you brought out comes just comes down. Okay, and that is your final answer. Okay, so this is a mix of greatest common factor and the product and sum. So sometimes you will have to do 2 steps before you can finish. The first one being greatest common factor. Okay, all right, next type of factoring is called grouping. Grouping problems have 4 terms. Excuse me. So, here's a problem that has 4 terms. So the first thing, like in the previous example, is make sure you don't have a common factor here. Is there a number that can be divided by all of these numbers? The answer is no, right? So once you have established that there's no greatest common factor, see what method it is. There are 4 terms, so it has to be grouping. So you're going to split the problem. So first start with these 2 terms, and then we'll handle these 2 terms. So for these 2 terms, like just, pretend that this was the problem. So what's the common factor? What number, is there a number that they can be both divided by, and do they have a variable in common? Pause the video and see if you can figure that out. So the answer is yes, 3. 3 can be divided by both. 3 can be divided into both, and they both have an x squared in common. Remember to always pull out the smallest variable. So 3x squared gets divided into each one, and you're left with x plus 2, right? Because when you divide 3x squared, that's what you're left with there. Now this middle sign, you always have to bring down. So bring down that minus sign. Now what can these numbers be divided by? 5x and negative 10, they both can be divided by 5. So 5 comes down.
So yes, better faces, mommy.
Okay, so now divide them each by negative 5, and you're left with x plus 2. Okay, Luciana, my daughter's interrupting me here. I am so sorry.
Mommy.
Okay, Lucy, abuela te está llamando. All right. Now, you notice that this x plus 2 repeats. That's what you want to happen. If that doesn't happen, then you did something wrong. Okay. Now you bring that down, x plus 2. Cross that out. And then what's left? This. And you're done. Okay, that is grouping. All right, last type of factoring coming up, guys, is called sum of cubes or difference of cubes. Okay, sum of cubes or difference of cubes, that is sock and dock, also known as. Now for these, this is 2 terms, and they
Hola, mommy.
they are cubes.
Hola, mommy.
Hola, Lucy.
Sale de un libro.
Sí, estoy leyendo un libro. All right. For these are usually cubes. Hold on a second, guys. Oh boy. Okay. So for cubes, You know it's a cube because I see a third power and I see a number here that has a number that you can multiply by itself 3 times. That would be 3, okay? Or in other words, a cube root. So now what you're going to do is bring down a parentheses and take the cube roots. So what's the cube root of x cubed? X. What's the cube root of 27? 3. Okay, because when you multiply it by itself 3 times, you'll result in the top. Now once you've figured that out, you're going to open up a longer parentheses. Start by squaring this. So x squared. Then square this, that would be 9, and put that at the end. Now multiply these two and take the opposite sign. So minus 3x. Okay? So in difference of squares, it has to be subtraction. But in the cubes, it can be an addition sign or a subtraction sign. Just always follow these steps. Again, the cube roots are here with the same sign, comes down. Then this guy are the squares, and this is when you multiply these two. But remember, always take the opposite sign. Alrighty, and you're done. Okay, that was a review of all the factoring that will be appearing in the next lesson. Hope it helped.